Hey, for those that are taking thermodynamics as a course, may know that the basis behind thermodynamics is to be able to figure out what's going on in each situation. A major difficulty that can be encountered by engineering students is the use of thermodynamics table to find the correct properties of the substance. So today, as a group of 4 people, we decided to explain you how to use them properly. And what a better way to understand those tables than going through a few examples. A quick recall before starting the first problem. Remember that we always need at least 2 independent properties to stipulate a state. For example, it could be the temperature, the pressure, the internal energy, or the quality factor, which tell us that the substance is somewhere between the saturated liquid and the saturated vapor. So in the first case, we are dealing with water. We are given the temperature and the internal energy of the substance. Knowing those 2 independent properties, we can absolutely stipulate the state of the substance. The first step is to open the temperature table for water at 150 degrees and make sure that the internal energy in the problem is between the internal energy for saturated liquid and saturated vapor, which is our case. At this stage, we know that water at 150 degrees and 1595 kilojoule per kilogram exists at a pressure of 475.8 kilopascal. And the phase type is saturated mixture since we are somewhere between the saturated liquid and the saturated vapor. So now the last step is to find our quality factor represented by X. We will use the following formula. Now do the math and try to find X. After computation, we will find 0.5 as a value of X.
Alright guys, on to the next one. We have a 600 kilopascal as pressure, and as internal energy we have 3477.0. So now let's take the table of the saturated water at 600 kilopascal and compare the value that we have of the internal energy with the ones on the table. And we must see if our internal energy is between the range of the internal energy saturated liquid and the evaporation. So if we compare our value with the ones in the table, we will realize that our value is far superior than the ones on the table. That means that we gotta go in the superheated table at 600 kilopascal. So now guys, go to the table A6, superheated water at a pressure of 600 kilopascal, and what you guys must do is find the internal energy that is very close to the value that we have, that is 3477.0. So if you guys do that, you'll find a value that is very close to the one that we have, and this value in the internal energy is 3478.1. And now that you found the value that is close to ours, check the temperature of this value, and it is 700 degrees. So now write 700 degrees Celsius, and because it's in the superheated table, the quality is nothing, like there's no quality. And for the phase type, we all know that because we found that we have 700 degrees Celsius in the superheated table, the phase type is superheated vapor.
So today, after my 2 other colleagues explain you how to get the values from the water table, now I will focus on how to get the values for a refrigerant 134A tables. First of all, the better way to understand it is to get an example with values. So let's try for a given temperature, which is 90 degrees Celsius, and a given specific volume, 0.0046 meter cubes divided by kilograms. The first thing to do when you have those values, you have to go to the table for the refrigerant, for the R134A, and for the given temperature 90 degrees, you have to make sure that for the given specific volume, the range, the value is within the range. Now we can say see that for the given temperature, which is 90 degrees, we have for a specific volume ranges from between 0.046 and 0.011949. Now we can say that we are in a good we are in the right spot for the specific volume. And when they ask you for the enthalpy and the temperature, you have to, since we are in the right range, you only have to read the temperature here, the pressure. Since we already have the temperature, the pressure is 3.2435 megapascal. You only have to read it from the values, which is on the right side of the temperature. And for the enthalpy, it is your H. Since we know that it's a saturated vapor, we will take the Hg and we read it, which is 276.32 kilojoule per kilograms. And to make sure that you get the right phase type, you have to go to your saturated refrigerant R134A, and for at the last of your table, and for your pressure, which is 0.90 megapascal, you can see that your specific volume is right. It is above of all the values given in the table. So you can confirm that you are right at your saturated vapor.
Alright guys, to conclude this video, we must understand that it's all about choosing the right table. In order to choose the right table, we must first know what we have in our informations. Let's say we have a pressure and specific volume that are given. We have to ask ourselves three major questions. Is our V smaller than Vf? Is our V between the range of Vf, Vg, or is our V greater than Vg? If the answer to the first question is yes, then we must use the compressed liquid tables, because in our situation we are in the range of the compressed liquid. If the answer is yes for the second question, we have to use the saturation tables, because we are in the saturation region. And if finally our answer is yes to the third question, that means we have to use the superheated tables, because in our case we will be in the superheated region. When we use these tables, we can get other informations such as the U, H, and S. And with basic maths, we can find data such as our quality X, and this helps us get all the information needed and then therefore use them in our problems. Thank you for watching this video.